we're asked to compute the derivative y prime of this curve, so we're going to use implicit differentiation. And we're assuming that y equals f of x close to the point of interest, which is when x equals 0 and y equals 0. So we differentiate both sides with respect to x, and we get the derivative of sine of x squared plus y with respect to x must be equal to the derivative of x squared plus 2x plus 3y with respect to x. On the left-hand side, we have to use the chain rule, so we differentiate sine of x squared plus y with respect to what's inside the bracket, and so that's cosine of x squared plus y times the derivative with respect to x of what is inside the brackets. And of course the derivative of the right-hand side with respect to x is 2x plus 2 plus 3 times the derivative of y with respect to x. And now we have a little more work to do on the left-hand side. That's cosine x squared plus y times 2x plus the derivative of y with respect to x. And the right-hand side is 2x plus 2 plus 3 times dy dx. Now we could solve for dy dx, but in this case we know that the point is x equals 0, y equals 0, so this equation has to hold when that is true. So when x equals 0 and y equals 0, we have cosine of 0 plus 0, which is cosine of 0, times 2, 0 plus dy dx is equal to 2 times 0 plus 2 plus 3 times dy dx. And of course cosine of 0 is 1, so we have 1 times dy dx on the left is equal to 2 plus 3 times dy dx on the right. And now we can solve for dy dx using simple algebra. We have on the right hand side 3 minus 1, which is 2 times dy dx, is equal to minus 2 on the left hand side, and we get dy dx equals minus 1 when x equals 0 and y equals 0. So of course the answer here is minus 1.